What I'd like to do is I'd like to intro solving trig equations. Okay, first of all, the big picture is first, whatever equation that you've been given, you must solve for the trig function. So in other words, if the equation involves tangent, you want to get tangent by itself on one side. That's our first goal. Then we want to keep solving the equation, but we then need to solve the equation for the angle. When we solve for the angle, we do this by drawing pictures of triangles, and we need to make sure that they're drawn in the appropriate quadrants. During this video, you're going to want to pause to write down the notes for the subjects that we're talking about. Okay, you might want to pause the video to write down these two ideas. Okay, now, another big idea is that the solutions to trig equations will always be angles. In other words, when I'm saying x equal to a number, if I'm saying theta equal to a number, that number is going to be an angle. Some problems ask you to solve over a particular interval. Most of them are from 0 to 2 pi. They usually include the 0. They don't include the 2 pi. Some problems ask you to find all solutions. And when we get to that point, I'll show you the technique for finding all solutions. Okay, you might want to pause the video and write down these elements. Okay, there's some details that we want to pay close attention to. First of all, pay attention to the angle. And what I mean there is the variable. In other words, if I have x in my equation as the variable, that x is representing the angle. Okay, or in this case, if I have theta in the equation, the theta is representing the variable, which is the angle. If I have theta by itself, that's what we call a single angle. There's going to be one set of answers. In other words, my theta values are going to lie in between 0 and 2 pi. I may be getting more than one answer for theta, but that's representing one set of solutions from 0 to 2 pi. If I think about 2 theta is what we call a double angle. There's going to be twice as many answers for 2 theta than there would be for theta. Okay? In other words, whatever answers we would usually get for theta, we're going to double all of those as far as the amount of answers. Not that we're going to be doubling the solutions, but we're going to be doubling the amount of answers. Okay? 2 theta lies in between 0 and 4 pi if theta lied in between 0 and 2 pi. Theta over 2 is called a half angle. However many solutions we got for regular theta, there's going to be half as many solutions for theta over 2. In other words, if theta lies in between 0 and 2 pi, theta over 2 lies between 0 and pi. Most trig equations, you will end up with 2 solutions if you solve them for the inequality 0 to 2 pi. Not all, but most. So for example, if I'm asked to solve sine of theta equals the square root of 3 over 2 on the interval from 0 to 2 pi, I will go into the technique here in a little bit, but just think about for a moment that square root of 3 over 2 is the same thing as y over r. There's 2 different quadrants that I can draw this triangle in. Okay, y is positive in quadrant 1, and it's also positive in quadrant 2. So I can draw 2 different triangles that would represent sine of theta equals the square root of 3 over 2. Okay, that being the case, there's 2 different solutions to this equation. There's an angle in quadrant 1, which we can see is 60 degrees, and then there's an angle in quadrant 2 that we can see is 120 degrees. Okay, so you do have to be careful that you're making sure that whatever value of the trig function you have, you're placing the value in the proper quadrants. And like I said, most of the time, not all the time, but most of the time, there are at least 2 quadrants that those values need to go into. And then number 3, be careful when you must use your calculator. There are certain problems that you have to use the calculator on because the triangles are unknown. In other words, they're not a 30, a 60, a 45, or something along those lines. In that case, we have to use inverse functions to solve, and we have to use the inverse function on our calculator. But the problem is we know that inverse functions have restrictions on the angle. And so what's going to happen is one of two things. The calculator, number one, is not always going to give you the correct answer. It's going to give you an answer, but it may be a reference angle, or it may be an angle that's in the wrong quadrant. Number two, the calculator will not always give you all the answers. In other words, if I'm supposed to be doing a problem like I showed you above, where I needed an answer in quadrant 1 and quadrant 2, the calculator may only give me the answer in quadrant 1. So I am the one that has to go and I have to draw triangles based off of what my calculator has told me, so that I make sure that I have the correct answer and I have all the correct answers. Okay, the calculator is used strictly as a tool in these sections. We, as the students, you guys are the ones that have to determine how to use that tool. So do be careful. A lot of times, we kind of think of our calculator as almighty and knowing, but you're always smarter than your calculator. You are the one that has to determine whether the answers it's giving you is correct or not. This concludes my lesson as an introduction to solving trig equations.